Going off-grid is the ultimate dream of self-reliance. But during the brutal dead of winter, a hidden predator is waiting to crash your entire power system, your own smart home. We calculate for big appliances like fridges and pumps, but we ignore the base load, the continuous, unyielding power drawn by dozens of interconnected cameras, hubs, and safety sensors running 24/7. When solar production drops to zero during consecutive stormy days, that silent standby load relentlessly bleeds your lithium battery bank dry while you sleep. To survive off-grid, you must implement power triage. The system must be engineered to automatically sacrifice convenience to guarantee core survival infrastructure. When battery reserves drop below 40%, the system executes a hard shedding protocol, completely killing power to security cameras, smart speakers, and media hubs. By isolating the parasite loads, your remaining battery capacity is locked down exclusively to power your water pumps, core ventilation, and medical equipment. True off-grid resilience means every automated circuit must have a bulletproof manual override. When computers fail, old-school physical switches keep you alive. An intelligent home isn't one that boasts the most sensors. It's one that knows how to survive. Master your baseload, control your triage, and claim true energy freedom. Your home is haunted by energy vampires. Even when turned off, ordinary appliances are continuously pulling power, bleeding your wallet and straining the grid in total silence. To stop the bleeding, we need to make the invisible visible. By looking through a high-resolution thermal imaging camera, the true scope of this wasted energy is instantly exposed. Every standby adapter, idle power strip, and smart display glows like a hot coal. That thermal signature is pure wasted electricity, radiating directly into the air as useless ambient heat. We map out the house room by room. The results are undeniable. These small, neglected hot zones aggregate into a continuous parasitic load that runs 24/7. Standard power strips offer a false sense of security. Even if the devices attached are off, the internal transformers inside the strip itself continue to draw vampire power from the grid. To kill the vampires, we install master mechanical interrupters. These physical switches ensure that when you turn off the grid sector, the energy draw drops immediately to absolute zero. Look through the thermal lens again. The hot zones vanish instantly. The adapters cool down, the circuits rest, and the invisible leak is permanently sealed. True sustainability requires vigilance. Audit your home, expose the phantom loads, and build an efficient living space that doesn't waste a single watt. Every smart device you own is slowly bleeding energy. We call it the phantom load, a silent, constant drain on our grid that is quietly eroding our net zero goals. A single smart plug uses barely anything, but multiply that by a dozen sensors, smart hubs, and voice assistants running 24/7. Together, they create a massive, hidden baseline energy cost. Look through a thermal camera, and the truth is undeniable. Those small power adapters and smart hubs are constantly warm, radiating wasted electricity into the air as heat. The real culprit? Constant cloud communication. Standard Wi-Fi smart devices incessantly ping distant servers just to stay awake, wasting power with every single byte sent. To reclaim efficiency, we must redesign the architecture. By switching from power-hungry Wi-Fi to low-energy mesh networks like Zigbee or Thread, devices only wake up when absolutely necessary. By migrating to a local-first system like Home Assistant on a single ultra-low wattage micro PC, your data stays in your house, and your energy stays in your grid. For the ultimate defense, we implement automated hard-kill relays. When you leave or sleep, the system physically severs the power to non-essential entertainment hubs, dropping the parasitic drain to absolute zero. Convenience shouldn't create invisible waste. With local networks and physical power cuts, we reclaim true net zero efficiency without sacrificing the intelligence of our modern homes. Even when turned off, your smart devices are never truly dead. They live in a state of perpetual standby, silently eating away at your energy grid. Turning them off via an app doesn't solve the problem. Software commands only put them to sleep, leaving the internal power supply fully energized and wasting electricity. The only real solution is a physical separation. We need to implement a hardware-based hard kill switch that physically cuts the copper connection to the grid. By integrating a heavy-duty mechanical relay into your central automation hub, we can automate this physical cut without losing the core intelligence of your home. When the house enters sleep mode at midnight, the automation triggers the relay. With a physical click, the entire entertainment and secondary hub zones are completely severed from the wall. The standby lights die instantly. The phantom load drops from a continuous 20 watts down to an absolute unbendable 0. As morning arrives, a single low-power master sensor closes the loop, instantly restoring power to your systems right before you open your eyes. True intelligence isn't just about automation. It's about knowing when to completely shut down. Stop the bleeding, control the circuit, and reclaim your grid. Your smart home is suffocating. Dozens of Wi-Fi smart devices are constantly screaming over each other, jamming your router and draining massive amounts of energy just to stay connected. The problem is the protocol. Wi-Fi was designed for high-speed data, not small smart sensors. It forces tiny devices to maintain a heavy, power-hungry connection directly to your main router, 24/7. But there is a better architecture. By switching to a low-power mesh network like Zigbee or Thread, devices don't talk directly to the router. They talk to each other, passing data down the line. Instead of keeping a massive communication channel wide open, these ultra-low-power protocols allow sensors to stay in a deep sleep, waking up for just a fraction of a second to send a burst of data. The energy savings are staggering. A standard Wi-Fi smart plug can burn up to 2 watts continuously. A Zigbee sensor? It can run for over 2 years on a single tiny coin cell battery. Because these protocols don't rely on an internet connection to function, your smart home automation works completely offline. Zero cloud dependency means zero internet bandwidth wasted. By offloading your smart devices to a dedicated mesh coordinator, your main router breathes easy, dropping its own thermal signature and processing load significantly. True intelligence is efficient by design. Stop overloading your Wi-Fi, optimize your protocol, and build a smart home that respects your energy grid. The ultimate flaw of the modern smart home isn't the software, it's the battery. Millions of wireless sensors are creating a silent, toxic mountain of chemical waste just to monitor our living spaces. But what if a sensor never needed a battery replacement? Enter energy harvesting, the science of capturing ambient, wasted power from the environment and turning it into electricity. We can harvest power from motion. By using advanced piezoelectric materials inside a standard light switch, the mere physical pressure of your finger generates enough voltage to send a wireless signal. We can also harvest light. Microscopic, high-efficiency amorphous silicon solar panels can capture the weak, ambient glow of your living room lamps, powering environmental sensors indefinitely. Even heat can be recycled. By placing thermoelectric generators on hot water pipes or radiator valves, the temperature difference between the metal and the air creates a continuous stream of clean power. The most radical source: radio frequency harvesting. Tiny metamaterial antennas can absorb the stray Wi-Fi and cellular signals already floating through your house, converting invisible electromagnetic waste into usable energy. Instead of short-lived batteries, these self-powered devices store energy in solid-state supercapacitors. They can charge and discharge millions of times without ever degrading. True sustainable automation requires no maintenance. By building a network of self-powered sensors, we create an intelligent living space that breathes, adapts, and survives entirely on its own terms. As global temperatures rise, our immediate reflex is to turn to technology. We overload our smart air conditioners, creating a massive power strain on our grids just to keep our interiors livable. But reactive cooling is a losing battle. Glass windows act as heat traps, allowing solar radiation to enter and convert into thermal energy. Your smart AC is merely fighting the symptoms, not the cause. The ultimate solution isn't found in advanced microchips, but in ancient geometry. By looking back at traditional architectural shading, we can stop the heat before it ever touches the glass. By calculating the exact solar angles of the solstice, we can design fixed external louvers. They completely block the high, brutal summer sun, while allowing the low, warm winter sun to penetrate and heat the home. When implemented, the results are immediate. The external shading system absorbs and dissipates the solar energy outside the building envelope, keeping the internal glass surfaces completely cool. With the thermal load permanently reduced by architecture, the smart AC no longer needs to work in overdrive. It drops its energy consumption by up to 70%, running only on low power. We can enhance this passive shield further with deciduous vegetation. Green leaves shade the structure during the summer, then drop in the winter to uncover the glass and harvest natural solar warmth. True net zero living isn't about buying more efficient appliances, it's about building smarter structures. Rely on geometry, not electricity, and let architecture do the work. Every time you toggle a smart light, your command travels thousands of miles to a distant corporate server cloud and back. This endless data loop is a massive, invisible energy sink. Relying on the cloud means your home is locked in a state of constant, power-hungry communication. If the internet goes down, your home's intelligence dies with it. The revolution starts by cutting the cord. By migrating to a local-first architecture, your devices talk directly to a central brain inside your own walls. No cloud required. Using open-source software like Home Assistant, we unify every sensor, switch, and camera into a singular ecosystem that processes everything locally, instantly. The best part? The entire system runs on an ultra-low wattage micro PC or Raspberry Pi, drawing less than 5 watts of power, barely a fraction of what standard routers idle at. Commands execute in milliseconds because data only travels a few feet. By eliminating global internet routing, we permanently drop the standby transmission load of your network. Your data stays in your house, your security is uncompromised, and your smart automation remains completely functional even during a total internet blackout. True tech self-reliance means reclaiming control of both your data and your power grid. Break free from the cloud and build a truly local smart home.